Hello, come on in. We will start in just a minute. All right, let's kick off. So welcome everybody to Cloud Native London. We are a strong, open, diverse developer community based on cloud native platforms in London. I am your host for the evening. I'm Cheryl. You can find me online at ocheryl.com. I'm a senior director at ARM, previously Google, Apple, CNCF. I've been running this for, 7 years, 8 years now. So it's been a while. Quite a few years, but it's good. Our agenda for tonight, we have 3 talks. So our first talk is going to be at 6:45, which is a better cloud native experience, all thanks to streams. 7:15, we're going to have a talk called Fleet What? Then we're going to have a 15-minute break, at which point please feel free to go outside, grab another drink, use bathrooms, come back at 8 o'clock for What Does It Cost?, which is our final talk of the evening. And then at 8:30, we're going to wrap up and go to the pub downstairs, which the conductor, which if you come out of the building, it's just in front of you on the left, and hopefully keep things going. Our sponsors for tonight is CloudBees. So Mike, please come on up and tell us a little bit about CloudBees.
Thank you. Good evening, everyone. Thanks for your time. I hope you're looking forward to the jam-packed agenda. For those of you who don't know, at CloudBees, our mission is to continuously redefine what's possible through software. So we're working with the likes of HSBC, BMW and Accenture to really accelerate digital innovation. So our main aim is to enable development teams to improve their productivity and build secure, reliable and scalable software at a greater pace whilst keeping an eye on compliance and an eye on cost control. So specifically, our platform looks to optimize the software delivery lifecycle, be that your CI/CD pipelines, test optimization, security and compliance, or feature management. Feature management is actually our latest addition to the platform, and you might have seen some barcodes and goodies outside. There's a trial on there that's ready to play with now. If you want to find out more, give it a scan. Equally, myself and Stu, give us a wave. My technical counterpart will be available if you've got any questions. But other than that, thanks for your time and have a good evening.
Thank you so much, Mike. Please grab some stuff on the way in or on the way out. And without our sponsors, we would not be able to keep this kind of evening running. So thank you once again. Okay, time for a little bit of live polling and to find out about you. So please grab your phones. You don't need to download anything. Just scan the QR code and it will bring up this service that will we'll do a couple of live questions and find out about you. Okay, just give a moment for everyone to get hold of this QR code. Okay. All right, there will be another. You can get the same one up there. All right. The Wi-Fi, you need someone from Just Eat to approve you to get on. So sorry, not easily. Yes, you should see a question. Is this your first time at Cloud Native London? And I can see people already submitting their answers, yes or no. Looks like we have pretty much 50-50 first timers and people coming back, which is something I love to see. There's always a handful of people in here who come every single month, and it makes me very happy. And also makes me very happy that we've got people joining. We're also live streaming to YouTube and to Twitch, so there might be some people at home joining as well. Oh, we hit 50-50. Sweet. Okay. Oh, the yes is just edging out. Okay. We'll keep going. What is your job title? Oh, this is looking a bit interesting. Whoa, look at these numbers on the right. These are supposed to add up to 100%. Okay. Looks like it's figured it out. All right. So, what's your job title? Architect, application developer, backend developer, engineering manager, DevOps/platform engineer, security engineer, or something else? And looks like DevOps and platform engineers at the top. How many? Say again. How many titles?
You had so many in the past don't know anymore.
You don't know anymore. Well, I know that feeling sometimes. Okay, sweet. It looks like we've got a nice little range, a bit of everything. Okay, our next questions come from the speakers for tonight. So, first question. Which of the following issues with cloud services have your team faced? Cold starts, file size constraints, slow auto-scaling, loops without protection, hard to find errors in logs, escalating costs, vendor lock-in, or none of the above? Give people a moment to think about this. I think you can pick more than one as well. And escalating costs might be coming out top. Where's Robert? Robert. Okay, so this question comes from Robert. Does this surprise you? Is this what you were expecting?
Look, not really. Definitely, people that go in end up finding the costs turn out to be a lot more than they were expecting. But it's unsurprising to see cold starts, challenges with logging, and other issues coming through as well.
Okay. Yeah, it looks like there's a bit of everything. Oh, I want to know who has none of the above. You have solved the problem with cloud. Good job. Okay, next question. Have you heard of Nutanix? So your options are Nutanix who? Yes, but why are they talking about Kubernetes? Yes, but only in passing. Versus no. Okay. Let's say we're going to 30 people. Not sure. Wait, so what's the difference between Nutanix who and no? Oh, where's Jake? Well, what was your question?
Yeah, curious. Nutanix have not been in cloud native space very long, so that's where these questions have come from. I'm not surprised, given our marketing budget's quite small, that no one's really heard of us. So yeah, looking forward to telling you who we are.
All right. Okay, sweet. Let's go to our third question. Are you using federated projects in your cloud architecture? Yes, no, or don't know. And I'm going to preemptively say, Stephen, you wanted to explain what you meant by federated projects.
This is just a concept of actually in Google, the implementation is we're using shared networking, and then each team or function has a project of its own to run its stuff in.
Okay, so let's see, we're getting a pretty even split here. So a third yes, a third no, and a third don't know. Okay, excellent. Thank you very much for joining the live bowling, but keep these open as we're going to do Q&A through this later on as well. Okay, I need a selfie for social media, so I'm going to do it from that corner. Everybody will have to smile and wave. Okay.
They were more enthusiastic back then.
And come and join us. Come and join us on this stage. So cloudnativelun.com if you want to come and speak, you want to sponsor one of our events and contribute to the community, or you have your own event that you want to promote as well. So you can do that all through cloudnativelun.com. And that's it from me. I'm now going to hand over to our first speaker. So round of applause, please, for Robert.
Am I using this? Hello, everyone. Hopefully you can hear me. I'm Robert Jeffery. Here to speak on behalf of MicroStrate tonight. And hopefully we've got something a bit different. This is actually the first time that we've spoken publicly about what we're doing. So until tonight, we've technically been in stealth mode. And tonight I want to just talk a bit about how we're making a better cloud experience and give you a little insight into how that's all being powered by streams. Oh, I know, I didn't share, did I? That was silly of me. Not a good start. There we go. That's better. MicroStrate. Better cloud native experience, all thanks to streams. Okay. So first of all, hopefully I'm preaching to the converted in this room, but the general consensus is that in modern times, the best web applications are built with what we've sort of coined a CHEM pattern. So they should be cloud native. Nobody wants to manage hardware and infrastructure anymore. They should be event driven. So there's a lot of real-time data. We're sitting here in Just Eats. They clearly have built an amazing business around real-time data. And thirdly, being microservices based. So that's all great in principle, and hopefully no one would disagree that tends to be the way we should be building applications in the future. I can try and get the screen to move. There we go. But the reality is that's actually very challenging for most teams. So maybe I should ask a quick show of hands in the room. Who's actually building or working with CHEM applications today? Who meets those three? That's good. That means I'm in the right room. Glad to see that. But it was, I would wager, probably around 15% of the room of all. And the reason why that's challenging is it's pretty hard. There's not many people that have done this, certainly at scale. So finding the right people can be really challenging, particularly if you're in the big established industries like financial services. They're built upon legacy technology. There aren't the people around to do that. It's actually pretty complex. There can be a lot of infrastructure to set up, and whilst there are tools available, actually there's still lots of different tools you got to use. It's time to get up to speed on those, and you can spend a huge amount of time trying to grapple with that. So, challenging. And then here's the kicker. So you think you're getting it right, and your application's going all right until you start getting scale, and there's actually a lot of issues that come across. And that question we asked earlier was because all of those things are things that we've experienced in the past, we've heard from others, and they're things that we're looking to solve. So what are they? Things like, if you're in serverless, you've got cold starts, services that are slow to scale, takes a long time to deploy things, lack of loop protection. If you're using streaming applications, often single-threaded, shards go to sleep, hard to scale, blah, blah, blah. There's lots of these things which actually are real-life problems that can impact your users and in reality mean that your development teams engineering solutions around these problems into your applications. And so from a TCO, total cost of ownership perspective, trying to get around these things is hugely expensive and ultimately at the detriment of your users. Enter MicroStrate. So for several years now, we've been working on this technology. It's a new paradigm for deploying and running high-performance web applications in a multi-cloud mesh. There's a lot to unpack there, and we're going to do a demo and give you some insight into how that works. But key three takeaways: it's highly resilient, highly performant, and first and foremost, we try to make it really easy to use for the likes of you in the room. Couple of key concepts. So first of all, it runs on a stream-based mesh, the MicroStrate mesh. And when you set up a mesh, you set up an account and you basically decide where do you want your workloads and your data to be stored and run. So you choose your location. We give you a choice of providers that ultimately the people who are managing the boxes in the data center. So we've got AWS and Azure and GCP and others. You can choose more than one and you can change your mind later. Very easy to just add another node into the mesh or take a node away. We'll take care of balancing all the data around. And this, of course, means that it can be really very highly resilient. With 3 nodes or more, it's quite feasible to get RPO 0, RTO 0. Next piece of secret sauce is our function execution engine. So we have our own proprietary streams that sit under the mesh, and then we've built our own function execution engine as well. And there's 3 sort of teasers I want to give you here around why that's different to other things out there. First is fast start technology. So we're taking snapshots into a memory stream that allows us to pause rather than shut down a function. And that means it can be restarted really quickly. And the resume starts take that status, and they're able to reinstantiate that. And that means that we can have stateful service functions as well. And then thirdly, we have a memory resource optimization technology in there. So leveraging the fast starts and resume starts, we hyper optimize the performance of the processor, and we basically allocate memory to those that need it at the time it's required. So we are gathering more data on this. We have users using MicroStrate already at scale, and we're gathering data, but we're starting to see those big benefits in terms of reduced energy use, and et cetera, because of our optimization of the processes. So I'm going to take you through a recording of something we recorded yesterday, just a demo that we did. And these are the things I'm going to take you through. So we're going to create and then update a function. So we're going to learn how we got versioning in place. We're going to show how easy it is to execute that function, to test it, to see the logs. We're going to look at some live logging and tracing of events being processed by function. And then we're going to just quickly touch on some of the other resources, which I haven't got time to take you through today, like our storage capabilities or access to streams directly. And then finally, I'm just going to show how easy it is to add a gateway so that you can expose that function that we've created out to the outside world. Any questions at this stage before we dive in? No. Excellent. Okay. So let's start this. So here we are inside a MicroStrate account. We've already set our mesh up. And one thing we're not showing today is our stack deployment capability. So if you've already got serverless or a Terraform template that you're using to deploy your existing infrastructure, we can take that on board and we'll create the equivalents out of MicroStrate's resources. But today we're going to demonstrate just going through setting up a function. So the first thing we want to do is to set up a collection for that function. So we're going to have a number of like-minded functions inside effectively a business domain. So we're calling that a collection. So there we have our Cloud Native London collection. Next thing we want to do is to go and actually create a function itself. So the function that we're going to show you first of all is it's actually a reasonable sized function. It's basically a rule engine piece of code. So we're going to be able to feed it a prompt. It's going to give us an answer to a rule. We've got that function already zipped up as a piece of code, so it's easy to upload that. That's storing that on our stream. And we're going to be able to go and specify how much compute resource we want to give this function. So we're going to go here, I think, for the performant one. So we're going to give it 1 gigabyte of memory that can utilize if it needs. And you know, we will manage that. And click the create function button, and off we go. So there we are, we've got our function. And next thing we're going to go and do is we're going to go and have a look at it. So we can see, first of all, on the left here, we've got a subject, we've got a log stream, so we know where we can see and review the results. We see we've got a version of that function, and that's already running. I wanted to show you how we can create another version of this. So we're going to upload the function code again. Likely it would be a different version. But what we're going to do at this time is we've actually decided we want to give it a different level of resource allocation. So we're going for the balanced mode. So it's 512. We deployed it. It superseded the other. We could swap back to the version 1 if we want. We could split between the two. But we're going to run version 2 here. So we're going to go in and test that. So we're going to go and paste in a payload, which is basically a rule that we're going to fire at our rule engine service. So there you go. We've got a 200 code. We've got the result, and we can see that response body. We can see that we've had the execution of the function, and we've got an ID for that. And we're going to go in, and we can see the function. We can see that one executed in 14 milliseconds. We can see what allocation was given to it, and we're going to be able to expand and look at the body that we passed in. And then also expand and have a look at the result from the function as well. Hopefully people would agree that this is a very simple, developer-friendly kind of UX that we've put in place. Okay, so next thing we wanted to do is just show how we can actually monitor a function as it's being executed. So we're going to upload another function. This second function is what we call a timer function. So it basically just logs out at a time interval an answer. So super simple. So we'll upload that, create our second function. We'll see it there in the list. We've left it in the same collection as the one before. And we're going to send that request and execute that. And we will see, again, we can see that execution is still occurring. It's logging out events as the function is operating. So we're able to see in real time those coming through. Again, we can see the total time for that execution. And yeah, basically we have a lot of, based on the stream-based architecture that's underpinning this, we've got a lot of observability around what's happening. We also have a stream dedicated to that function. So I can look at the stream and I can look here. It's actually a live list. So we can pause the list, but we're actually got a live list. Nothing's been executed at the moment. We can specify a period of time and we can see here the transactions over, I think it was set to 5 minutes. So there's the final result function, but we can also go and look at each of the individual events as they're happening as well. Again, this is all in one tool, so it's really easy to see and monitor those as they're coming through. Very auditable. And then I'm trying to remember what happens next with the video. I think what we're going to do is just touch on some of the other things that are there. So we actually have the ability on our mesh to store data. So we have a KV store. So we've got a bucket there set up for those assets. We've got a large object store. We've got index stores as well. So if you've got data you want to store inside the mesh, you can. Or, of course, you'd be able to pass that data out through to another storage service externally. And then the final part of the demo was I just wanted to show you how easy it is to then expose that function that we've created inside this mesh account out to the outside world. So we're going to go and set up a gateway. Our gateway supports API, WebSocket. It's got heaps of middleware options. It's very fully featured. So there it is. We've set it up. We can then go and manage the gateway. We can give it a path. So we can give it some mappings. So I'm going to give it a path. And then what we need to do is, this gateway, of course, we need to point it at something. So if something hits, the request hits its gateway, if it passes the validation that maybe we put on as a mapping, the middleware, then it's going to go and hit this function. So we're specifying it's going to hit the resource type that's a function. It's going to hit that timer example. And basically when we pass something in there, then obviously that's going to run that execution. And that's it. We're up and running. We're able to go and hit that function straight away. I will pause. That's the end of the demo video. Is there any questions at this stage? No? Go ahead. Sorry, I'll walk over. We're good. We're good.
So my question is related to ability to pause and resume stateful functions. So do you have any sort of way when that function maybe, I don't know, like dealing with long-running connections, maybe it's connecting to not your store, but some sort of database that is exposed. So how it will handle resurrection or resume if that connection will be already stale without any delays or like cold starts?
Yes,
We do.
Yeah, I mean, like reconnection is all right, but you're looking at their like a timeout first of all.
Yeah. So once it goes stale, so it'll resume as long as the connection's not stale.
Mm-hmm.
But the timeout still has to be handled because obviously you're reinstantiating a stateful function. It's got all of everything up and running, but it still needs to be connected directly to the database if it's timed out. So that still has to be handled.
Okay, so there are still possibility of potential delays.
Yeah.
Okay.
Basically, your application needs to handle that timeout. Yeah, why Zoom died on me? It's not good. Surely it's not because I walked across the road. It's not that far. Okay, I'm going to try and get that Zoom connected while I'm talking. So The next thing I wanted to just show was just to sort of round things out, was just to touch on the performance. So we're in a private beta mode at the moment. We've got clients using this. Literally trillions of events have been processed already on this technology, but we're about to bring this out. We've been doing some performance testing, and in fact, we did some testing this morning with the function that I showed you. I'm just going to try and reconnect back into Zoom. Give me 1 second. See if we can connect back. Don't think my phone light being that far away from the computer. I should have left it here. Two seconds. Join. I really want to show you this slide because it is quite interesting. Okay. So yeah, we did some performance tests. So what we did, we took the function that I've just shown you in the demo, which was the run rules engine function, and we ran that 10 times in MicroStrate. We then ran it as a Lambda function on AWS 10 times as well, and these were the results. So on the first run, it was the first time that we'd executed that function on MicroStrate. That actually took 14 milliseconds, as you saw in the demo. That was about 64 milliseconds, I think, when we ran that on AWS. We then left it a few minutes. We ran the function again in AWS. It'd gone cold, so that took 57 milliseconds. We got fast start technology on MicroStrate. It was running about 0.8 milliseconds on MicroStrate. We then ran both in quick succession a further 8 times. And look, I appreciate this is just a sample, but this is the indicative of the kind of results we're seeing. And MicroStrate was 2.3 times on average faster at running that same function than running it on as a Lambda on AWS. So look, hopefully that gives you some insight into sort of what we're doing. And there was 3 key takeaways I wanted to leave. One was time is money. All that time you spend deploying and managing your cloud native infrastructure and your applications costs money. It means you takes away from delivering features, etc. We're trying to solve for that. Our stream-based logging is making it easier to diagnose errors, particularly with complex distributed microservices-based systems. That real-time logging is a real advantage. And that speed, scalability, and resiliency are critical to reducing TCO and solving those issues with your applications. When a cold start hits in, that has a big impact for your users in most cases. We're interested in hearing your thoughts. We have a website, microstrate.io. You can sign up on there, fill in the contact us form. If you think that you've got a use case that would be suitable for our private beta, we'd love to talk to you about that. We're going to be live in production very soon as well. So yeah, please connect with us through there, and love to hear from you.
Hold on a moment, I'm going to take over the screen share. Okay. All right. Thank you very much. Remember, you can type any questions to Robert on your phone, or you can have the orange box. Yeah.
Heather, how does using a platform like that provides abstractions fit in with kind of IAC practices and trying to keep everything in code and reproducible?
Good question. So, I mean, I'm not entirely sure what you mean by the question, but everything is reproducible, obviously, in the code that we have. So from a deployment perspective, you've got that in, say, a serverless or Terraform, or in time we'll support others. And basically, we will read that and we can go and take that code for the deployments, and so that can come straight in. From a function perspective, all of that code's in there. We have the full version history. It's all stored on a stream. Everything's there as well. Does that answer your question?
Yes, I think so.
Okay. We can chat afterwards. Happy to. Thank you.
Anyone else? Da-da-da. Going once, going twice. Okay. All right.
Thank you.
Very much, Robert. Another round of applause, please. Oh, actually, I'm live. Some questions actually came up while I was looking it up. Okay, how do you take good care of security compliance?
Topic close to my heart as an ex-risk guy. Well, first and foremost, from our perspective, so we obviously have ISO 27001 and other security credentials and all of that sort of stuff that we need to have for contract purposes and independent pen tests, etc. So you know that you can trust us. From a security compliance perspective, several things. One, the MicroStrate account really operates on a zero trust basis. So any data processed in there as part of the account sign-up process, you get private keys and backup codes. We have no access to your data whatsoever. So don't lose those keys. That's pretty standard in terms of how things work. All of the, again, everything is operated on stream, so we have a full history of everything that's happening through the platform, and in fact, you do. So that's actually a huge benefit from a compliance perspective, that it's fully auditable in terms of all the activity that's happened on there. I mean, that's next one as well. So how does it compare to Lambda in terms of costs, specifically that MicroStrate is always hot? Well, technically, it's not always hot. So we keep a snapshot in memory, so it's hot and ready to go, but actually, it's still virtualizing that execution at that point in time. From a cost perspective, we've been working really hard on that. One of the challenges we see, and obviously it was the most highly scored answer on our question earlier, cloud costs going through the roof. We've actually adopting a much simpler model in terms of being able to bill for these services. It's all in the one platform. It's a usage-based model still, but using credits, and we've actually got some kind of unique, we think, twists in terms of how we can make it simple to understand your bill and predict and manage your costs on an ongoing basis. So the short answer to that is we expect to be cheaper than AWS or others.
All right, thank you very much. I am now going to hand over to Jake, our second speaker. Round of applause, please.
You want HDMI and Zoom or just Zoom? I'm using this, right? I'm still not used to hearing myself on microphone in the background. So I'm Jake Tame. I'm a solutions architect at a company called Nutanix. I am going to be covering Fleet What, but because 50% of the audience don't know who Nutanix are, I'll set the scene as well. Some of you have heard of Nutanix, but you may not understand why we're actually talking about Kubernetes. So to set the scene, Nutanix is a cloud platform. Okay, we run on physical infrastructure in your own data centers, x86 hardware. We're agnostic to that, 17 odd hardware vendors. We also take that same software construct and run that on bare metal in public cloud. So think of EC2 bare metal. Google is announcing at their .next shortly, and Azure is got a custom service for us as well. So we can deploy a software layer across all cloud environments that enables true portability of data. So if you want to replicate from on-premises to a public cloud environment, we can do that. Not for just virtual machines, but for container data as well. So we'll talk a little bit more around how we do that. It is a suite of products. You don't have to use all of them. There are multiple facets to that. We have a build your own DBaaS platform, for example. Think of that as a comparison to like Aurora. So whatever you may want to build as your own, we have a potential option for that. Like you talk about cloud costs, MicroStrate could in theory run as a virtual environment on top of Nutanix, right? And when we're doing this cost comparison, on-prem is always cheaper, right? Everyone knows that. But how do you get a public cloud-like experience in an enterprise data center, right? That's automation, speed of delivery, IAC. We have all of that capability as part of the stack. So as you start building out, you then have the same experience both on-premises and then in public cloud as well. So versus having different skills across different clouds plus on-prem, you've got just that platform engineer that's looking after Nutanix. I was at Kubernetes Community Days, I think it was back in November, somewhere else where it was. I think it was November. the top two topics that were there were platform engineering and data operations for Kubernetes, right? And Nutanix have simplified that for core virtual machines. We've been doing that now since 2009. We're now in the space of Kubernetes, right? And there is Kubernetes everywhere. And the core thing around Nutanix is we've not really been in that space very much, right? So up until 16 months ago, we didn't really have a Kubernetes offering, right? We had what was called Nutanix Kubernetes Engine, which was a very basic, I can give you a kube environment, but it didn't really solve any of the Kubernetes challenges. So we invested in a acquisition called Day2IQ about 16 months ago. This company founded one of the original enterprise versions of Kubernetes back in 2016 called DKP, which was their Kubernetes platform. Prior to that, they were sort of the original founders of Mesos and Mesosphere. So they've been around in the industry a long time. They're now part of Nutanix. So we've got all the engineering, all the product staff. So we're effectively a cloud native company from a marketing perspective, right? That's not our core bread and butter right now, but this is why I'm here. We're building out a developer community. We've got boot camps coming up. We're at KubeCon. We've got platinum sponsorship at KubeCon. So S210 is the booth, if anyone remembers that. So look, we're investing heavily in the cloud native space. So what do we actually do, right? So we've spoken about the virtual machines, core platform, cloud platform. We understand that a lot of difficulty in Kubernetes environments is data operations, right? A big complaint is how do I upgrade it? How do I maintain it, right? When you actually think about the life cycle of building out what an environment looks like, the container runtime environment is only about 30%. A lot of the integration into the enterprise environment is day two, right? Who am I talking to? How am I doing upgrades? Observability, right? DevX experience, IDB platforms, right? How do I have that good experience for developers? So we've turned DKP into NKP, Nutanix Kubernetes Platform. And there's a very pretty diagram on the screen, but it gives you a suite of things. Okay, it's CNCF compliant vanilla upstream Kubernetes as a base foundation. Okay, so we can deploy that on any infrastructure, whether it's x86 bare metal or public cloud. We can actually even provision EKS and AKS clusters. So this is where the agnostic part comes in, right? It's detached itself away from the cloud platform that Nutanix provides for virtual machines, and we can provision it anywhere. We call that the fleet management side of things, right? How do I actually manage Kubernetes distributions in multiple cloud environments through a single control plane? Then you've got some competitors that can do it. You've got Anthos, EKS and AKS and those various things, but it's still quite complex. It doesn't necessarily run on premises very easily. And who I talk to is financial services customers. And Rob asked me, who's doing containers? About 10% of customers I talk to are actually doing containers in enterprise large-scale environments. And it's predominantly around all of the day two. How do I actually support this in a production environment? I could go and build my own vanilla Kubernetes environment. I've got an example customer that they've had for 2 years a vanilla Kubernetes environment that they built themselves. They won't take it to production because there's no support for it. And that's through regulation, auditing, and compliance, and those things that come along with it. So we've got the core foundation of providing a VM layer, a Kubernetes layer, but then that spans multiple cloud environments as well. So when we look at actually what that's providing, is you're thinking, okay, it's just another EKS. It's sort of a bit beyond that, and we'll walk through why it's a bit beyond that. We introduce full lifecycle management. So we take on the ownership of kube version upgrades, but also all the tooling that we add into the environment, which I'll talk about in a second. And then we do that for EKS as well and AKS. So if you choose us to provision those platforms, we can do lifecycle management for those stacks as well. So it's a very cool integrated stack environment. Another unique option is the introduction of pre-provisioned. So if you've already got Kubernetes environments deployed, which more than likely everyone here probably has, how do I then take advantage of those? We have the option to onboard pre-provisioned. You then gain all of the fleet management aspects of the stack. So all the role-based access, the catalog management, the lifecycle upgrades, the operations, the observability platforms. So we can actually adopt what you've already provisioned. So none of the stuff is wasted. It just makes it a little bit easier. We also are very aware of compliance. So from the foundation of where NKP came from was Department of Defense in the US were like, we want a secure FedRAMP, dark site approved Kubernetes environment. So not only are we fully online, we can do complete dark site deployments that are FIS approved and also CIS approved. So we actually provide CIS runtime images that you can then use and deploy. We then add on top of that where you can then say, I've got Trivy, for example, and I've got all these CIS benchmarks that I need to provide compliance on. We will do all the monitoring of that through our Insights platform. So we'll actually flag up whether you're in compliance or not. So this is part of sort of the advanced user support of day 2. Okay, so we start monitoring all of your Kubernetes containers and saying, how can we actually help you on the day 2 side of things? As part of that, we have root cause analysis for potential issues as well. So we call it AI. I'm going to throw AI out there because it's a hot topic in Kubernetes as well, right? So we have sort of machine learning / AI built into the stack where we can start doing root cause analysis of potential faults, right? So you can chuck in an error into our chat and it will potentially help figure out what's going on, give you all the commands. You're thinking, why do I need that? I'm a Kubernetes expert. We talk to people, they struggle to find the skills. So how do we make the adoption of Kubernetes easier for enterprise organizations? Day 2, right? It's all about day 2 experience. If you think about platforms and how you provision, we're very much more aimed at like the infrastructure traditional administrators, where we give you a very easy CLI to deploy. We give you very easy UI to deploy. But everything we do is based on CAPI or CapEx. Right? So you can just use standard YAML and you can push out a Kubernetes environment. Right. What's actually included? Where's the value add? So not only is it upstream Kubernetes, we follow the 3 yearly release cycles. We actually govern and support all of the product stack you see on screen. So what we do with that is we take about 30 CNCF products. Most of them are what most enterprise organizations will use anyway. And we own the lifecycle and interoperability between all of the other products in the stack. So we own the versioning and we own this upgrade of those tooling as well. Okay, so it removes a lot of the day 2 headaches of, does my Prometheus work with this Locky version, right? Does my Fluent bit work with X, right? We take and own all of that. I'm thinking, great. We also support this as well. So you can phone Nutanix for support. If there's an issue with a catalog item, it's what we refer to them as. If there's an issue with that, we will support you. So you then gain full production support for a Kubernetes environment, including all the tooling off the back of that as well. Okay, quite cool. Some of the things that are unique to Nutanix is something called NDK on the top right or left, depending on how you're looking at the screen. Nutanix NDK is a database service operator for Kubernetes. We then have full cozy operator as well and CSI driver. So if you're running on our virtualization platform, you gain access to block level storage performance in a container runtime. Okay, so quite cool. I got a very bad animation. There we go. So added today, new version of NKP released. We've added cloud native PG and Harbor image repository into the stack. So we now own and govern those things as well. So we are innovating, we are developing the platform, and like it's based on feedback and demand of what applications we can import. So new version today that adds those 2 functions in. What does NDK do that is unique? So common thing that I find difficult when talking to organizations is, I've got an EKS cluster, I've got an on-prem Rancher deployment. How do I get the data between the 2? There's a couple of offerings that might be able to sync the replication between the 2 environments. What about Nutanix? We've been doing storage for 15, 16 years now. We've got an enterprise-grade storage platform, NVMe performance. Why not just present that through CSI to the containers to offer stateful applications? The question is, should we be doing stateful or should we be doing stateless, right? Containers was all meant to be stateless all the time, and then we developed stateful. So hence where cloud native PG comes in. We can provide persistent storage for all container applications. What NDK does, it gives the developers custom CRDs where they can specify what RPO and snapshot replication they want to any other target Nutanix cluster. So you gain full hybrid multi-cloud replication for containers. Alongside that, NDK can run on Nutanix. For example, if you have Nutanix on-prem, Nutanix bare metal cloud, and you want to use EKS, which we support deploying, you can actually just talk through CSI to the storage platform that sits inside your AWS tenant and account. So you then have a full replication from the EKS to something on-prem. Okay, so it's quite a cool, unique offering. Alongside that is the snapshot cloning methodology within that CRD as well. So when you think about CI/CD, what's difficult? How do I actually test this stuff with production databases? Cloud native PGs running, I can then schedule a snapshot to take a copy of production, do some obfuscation, put that in a development environment, and start doing my code-based testing on it. We then talk about a database layer, which we'll talk about a little bit later, that offers some unique things on top of that. So it's full self-service because it's Kube, full self-service for day 2, and enables that automation side of things. So we're covering off the cloud admins, platform engineers, and your developers as well. So what this looks like is we've got the construct with CAPI and CapEx. We've got a management cluster. Once that's provisioned, that can be provisioned on anything. So that could run on EC2, Google VMs, Azure VMs, wherever it may be. You deploy your management cluster, that then acts as your CAPI into other provisioning methods that you want to deploy on. So you get a single UI or a single API that then allows you to provision once you've actually spun that up. As part of this, we like to think of it as the fleet management. So when you think about all those distributions, potentially worldwide deployments, I've got 1,000, 50, an example I gave earlier to Robert was customers got 50,000 Kubernetes cores. How do I manage that from a day 2 perspective, right? If that's running on bare metal, you've then got to also manage all of that bare metal upgrades, lifecycle management, security, observability. How do I do skip versions? How do I maintain 3 yearly updates a year on all of these products, right? So a lot of the value that we're offering is fleet management. We've got an ex-CIO of a large bank that works for us now, and this is his favorite thing. We had a conference last week with 1,000 people, and fleet management was probably his favorite word because actually it removes quite a lot of the burden on staff. Like I mentioned earlier, we can actually import pre-provisioned. So this just enables you to continue developing on your existing Kubernetes platforms, but you gain access to all those catalog items. Okay, so if you add your pre-provision into Nutanix, you can then go and deploy Prometheus, Grafana, Loki, FluentBit, whatever it may be, on top of your existing. It doesn't stop there. You can import your own catalog items into the stack as well. So when we're talking about fleet management and application deployment across the globe, you add in your Helm chart or your YAML, whatever it may be, and you can import that into your catalog. That then enables you to give developers self-service access to particular projects or resources or clusters where they can only go and provision that application on top. Something that we're working towards is sort of flat car support on-prem and also multi-cloud. It's only supported in sort of AWS and Google for now, but what we're doing is bring your own OS. Okay, you define what your OS looks like. So any security practices, any hardening that you do right now, you can import that into NKP and then go and provision that on any cloud. But again, we do provide a built-in managed OS for you. Great. What about automation, GitOps? How do I actually do provisioning of my containers? So we use Flux, and we have a Flux running in the management cluster. We can then just monitor a Git repo, and we will go and provision. Again, we're talking about CAPI and GitOps. You can actually do a full deployment of a Nutanix cluster through our own Flux operator. So you define what your YAML looks like in your Git repo, and then you can go and start provisioning Kubernetes clusters from a CAPI perspective. Conscious of time. So typically, what is the benefits of using NKP? For us, it's the fleet management piece, catalog items, hybrid multi-cloud, data services. There's a lot, right? I could talk for ages just about the capabilities. It's better together. It's kind of like what we're saying is you choose your right Kubernetes platform, but we can help manage it for you, right? We want to be agnostic. Yes, it is another vendor that you're going to be using, but hopefully you see the value that there is lots of things that we can. You don't have to use them all, but ultimately we're giving you all of that data insight into an AKS or EKS cluster that we spoke about. Let's talk about architecture. We've mentioned we got an NKP CLI. It's about 10 environment variables that you set, customize what that looks like, and then you just do NKP create cluster. That does your CAPI of your management. Once you've done that, you can then use UI or, again, NKP to go MKP create EKS cluster. You've got 4 variables for an EKS cluster. So very easy to go away and provision and adopt. And then that does the full lifecycle management, all container pull downs. Make sure you log in with Docker.io logins, although you're going to get rate limited, but otherwise it's fairly seamless. 2 models of environment types. We've got single cluster. So you can run a management cluster with workload nodes in that as well. But typically what we recommend is a dedicated management cluster. And then you've got your potentially attached clusters from GKE or AKS, etc., etc. We'll talk about those. So this is probably the slide that you're probably most interested in. It's got all of the functionality, all of the cloud provider choices as part of that environment. So if you want to take a snap, and there's 2 things to this. One is you've got CLI for people that like that. You've got a pretty GUI. We'll show you a demo at the end. AWS was playing up, but so I'm going to show you a video. Something that I quite like, having been sort of a DBA at a commercial bank, is I've got a 10 terabyte database. I've cloned that 100 times for development work because that's what we need. Our database offering gives us a custom CRD for container deployments. So that means that you can give self-service access to provision a MongoDB instance, a Postgres database, an Oracle RAC environment, or a SQL server on any target Nutanix cluster, all through CI/CD pipeline. So when you're thinking about other databases that you might have to integrate into from a container perspective, we can snapshot and clone and provision those as well. And actually down to the second based on sort of T-logs that databases have. So a full bring your own DBAS platform. The key thing is you can actually integrate into developers. Why is that a benefit of running it on Nutanix? So I take that 10 terabyte database, I clone that, but we use 0-byte copy. Okay, so I can clone that 1,000 times, and I might only see a terabyte increase in said storage usage. Unless you start modifying those tables, we're not going to be changing any of those rows or data, therefore we're not consuming any more data. Okay, so it enables effectively a 10 terabyte database to be cloned in a couple of minutes and put in any cloud environment. So as you start doing development work in production, development work in cloud, cost-wise, you then bring it back on-prem. We enable that full data replication for databases as well. Like I say, custom CRD. Customer case studies, can't really share any names, but ultimately build out what this looks like. And this is a bank in sort of Dubai, 3 sites that they want to deploy onto. NDK is the streamer between these cloud environments. They've got NKP, OCP, and EKS. And ultimately, CSI driver can talk to all of those, and I can start replicating between them all. Right now, NDK is just an async, so we can offer sort of a 1-hour RPO. So that is then going to just mean that it's sort of a slight delay. We do have Valero built into NKP, so we can do full BCDR as part of the process. But coming soon, we've got synchronous replication for container data. Okay, so that will then mean that you can do some pretty cool fast stuff, replicate globally. Obviously, there's a latency requirement, so sync is what it is. Where we're going towards as an organization is, like I say, we're very much cloud native focused. A lot of the tooling that you saw at the beginning that we have as applications, they're a mixture of sort of monolithic virtual machines and appliances. Some of them are running inside Kubernetes in our own stack. A lot of that now that we're building is building for cloud native ourselves internally. So products, you can then run them anywhere. We call that Project Beacon, so you can Google that and it will spin up what we're doing. The first iteration of that is our AOS storage layer running as a cloud native AOS inside containers. So all of the storage replication effectively becomes containerized, which means you don't need CSI, you get NVMe performance, low latency, and then that gives us the full replication, including data resiliency, quasing, data efficiencies like compression, erasure coding inside the container world. So that's available for EKS right now. So it's not, we're not even building that for our own platform first, right? NKP, we built that for EKS because customers said we need this, so we developed it. So we've got a lot of cool engineering built in into the stack. So synchronous replication, again, is available through this technology. AOS supports 0 RPO. So if you want to run early access, we can run early access for our cloud-native AOS on EKS clusters. And a thank you. I'm going to talk over the video, and I'm going to run it at 2 times. This predominantly shows you video, but if anyone wants anything else, we can do full demos and show you CLI and all that sort of stuff. But ultimately, we can see that. Did I hit play? I didn't even hit play. There we go. We're sort of trying to appease the infrastructure teams that we predominantly talk to in Nutanix to say, look, Kubernetes is difficult, right? We like to say it's easy, but it's easy if you use NKP. It is actually quite hard to do Kubernetes. So how can we make life easier for the infrastructure teams in enterprise world that are being asked to provide a Kubernetes environment? NKP does that. So as we work through this, we're creating a workspace. That workspace is GPU operator, for example, for an AI workload. That workspace, you can have multiple clusters inside that and potentially different applications enabled. So we have full observability with Grafana and Prometheus, Fluent Bit sending metrics. We've got Jaeger doing tracing, and off the back of that, KubeCost if you want to start actually recharging back to the business. So all of the enterprise-ish features that organizations need, we've got included. And it's very, very simple to go in and create new projects. Projects is where you assign your GitOps and your repos to look at. We can see we're going through and enabling continuous development. You can see in there we've got quotas and limits, so you can actually define how much resourcing you want to give to your developers or production, for example. You can attach to secrets. We actually do secret lifecycle management through Cert Manager, right? Something very difficult in the real world. Network policies of ingress egress, right? What's the actual rules? We use Istio service meshing, and Cilium, right? So when you talk talking about EBF and all that sort of stuff, we support all of this from a capability perspective. So very easy interface, but everything you do with Kubernetes right now is still applicable because we're just vanilla. So thank you very much. Spot on half an hour. I'll stop. Of course you can.
Box.
You said that you support basically bring your own image, allowing your customers to get any sort of like a hardened image.
Mm-hmm.
But how do you deal with dependencies? Because image may be slightly outdated. There might be something that is blocked that may be needed for your service.
Yeah, good shout. We do have a compatibility list, right? So when we say bring your own image, there will be a versioning supported matrix of what's supported, and then we'll also go from there.
But will it also check that it's compatible? So
Correct.
I can basically drop my image, and then if it says yes, then it will
Correct.
work. Okay.
Yeah. So what happens is you provide your image, whether it's CIS hardened, whatever it may be, we then add in all our requirements on top. Okay. So you just give it us as vanilla image, and when we add everything in top that's needed.
Awesome. Thank you.
Anybody else? Okay. Oh, Stephen.
Hey, you mentioned that coming up you have very low latency replication. How are you doing that?
So our architecture for AOS, so Acropolis operating system, is been built by ex-Google engineers. So Google File System, for example, we followed Paxos and key value stores and all that sort of stuff. So we've built the core foundation of the storage platform. That's got replication built in. If you've got NVMe, as long as you've got low latency, that same concept is just in container world. So if you understood our AOS storage layer and how we do very low latency, it's basically pass through NVMe over TCP fabric into our controller or container in this instance, and then we just redirect the guest VMs or containers into the storage layer.
Yeah, I think my question was what happens after that, because it's actually quite complicated. Maybe I'll talk to you afterwards.
We'll go deep dive if you like to. Yeah. Thank you.
All right. Thank you very much, Jake. We are actually running slightly ahead of schedule. So we're going to take our 15-minute break now and then come back 7:45. So we'll start 7:45 again. Okay, see you in a little bit. and then stage is all yours.
Thank you.
Testing, testing.
No. See?
Always present. Very shiny window.
Yeah, I can see the reflection.
Or you can see the reflection.
Oh.
I guess we're going to stand like this. So you can...
Hi everyone, and for you, those of you who've stayed, thank you very much for being here. My name's Stephen Pereira, and
I'm Özgür Uyar.
and we both work here at Just Eat in data platform. This talk is on workload management. So this is how we have refined and looked at how we run workloads on our data platform. Okay, so just very briefly about us. So I'm a Londoner and working in the industry for a long time, at least a couple of decades now. I started in hosting in data centers, built private clouds, worked in public cloud, moved applications, and
Yeah. Yeah, sorry. So I'm originally from Ankara, Turkey. Before coming here, I lived in Tokyo and Dubai. If anybody wants to talk about those experiences as well, I've been in the industry mostly doing data engineering on different company sizes since 2011.
Yeah. So there are currently 7 teams, I think, in data and ML ecosystem that we work with, around 50 people serving thousands of users all over the company. And we're, multinational. So we have teams in Ukraine, Amsterdam, London, and Australia, Canada, all over the place. So I think I joined in 2009. It's been almost 6 years now, and just working mostly in the data space.
Yeah, I joined on October 2023. I joined as the manager of a core data team, which was before a reorg we did in data platform. Now I'm leading the streaming and ingestion team.
Yeah, and part of my role is to help us with planning for the future, strategy, architectural changes, as well as making things work and connecting people in the teams.
Our team's main responsibility is bringing data real time into BigQuery, providing that as a self-service. We're also working on stream processing at the moment. And with Steven, we collaborate on a lot of things, but I'm also responsible for capacity and cost management on BigQuery, which is the topic of actually today's presentation.
Yeah, so this is the obligatory slide from Just Eat. We are in 17 different countries. We have millions of customers and millions of orders, but all of those, they flow into the Just Eat data platform. This is a little bit about us. So we work on streaming, but we're kind of, I think this is a little bit out of date. We're at least, I think, 1 billion messages a day now. We have thousands and thousands of batch jobs running on specialized airflows that we create and curate for our teams. Dozens of projects and multiple GKE clusters, airflow, data flow. If people use it, we probably have it somewhere. And, we serve thousands of users all over the company for visualizations. Okay, so subject of the talk today is what happens when you have big mergers. So in early 2000, Takeaway acquired Just Eat, and then we had this kind of wait. We were looking at what capabilities we had in different platforms, data processing capabilities in different clouds. And looking at both clouds, we chose GCP to keep processing our data. So when we looked at the current state of what was in both clouds, like how we tried to identify what was running and the problems we had when we tried to look at how to run it all together and manage it is kind of what we're here to talk about. So this is what it looked like in Takeaway. We had a provisioned cluster for Redshift, so people were adding nodes to it. You get manual and dynamic workload management, but the teams there told me that they had some problems at that time with workload management. So they were kind of unfortunate. They had in a kind of throw it over the fence style teams that were running code on top of a data platform and just giving it to them and saying, hey, make this run in a lot of cases. There was a lot of looking at those queues, lots of trying to figure out which users were doing which things, trying to make things run faster. And at the end of the day, if it's a provisioned cluster, they were just adding nodes for capacity when they ran out of threads. So BigQuery is different. BigQuery is serverless, truly serverless, scales amazing. At the time, we had projects assigned to 3 main reservations, and we were quite clever with our commitments. So we bought commitments, but at the time Google offered the Flex API, so we bought slots on a schedule for our sort of kind of predictable batch workloads. We'd kind of worked out what was running when and scaled appropriately. Now, then came another twist. So just as we were about to migrate, Google introduced editions for BigQuery. So if you haven't seen it, kind of the unit of work in BigQuery is a slot, and it's kind of like a kind of a virtual entity for CPU and memory and a little bit of network, the things, resources you get in a database. What they did was they gave you a lot more options. So you could share idle slots between projects. You could, in a way, a bit like in a CPU with a share in a CPU, you could assign some slots from the commitment to one project, and if there was contention, then it would get those. You could then also assign autoscale slots. So within a 60-second lag, if you had workloads that were running and you didn't have slots available, it would just scale up and follow the curve and then release them. And it's worked really nicely. So I've talked about this before. We're huge fans of Dora here. You've probably heard of Dora metrics, but if you haven't seen the model, go to the website, look at the capabilities, look at the things that in research shows that high-performing technologies teams in technology do. Sorry, my bad. So some of the things we talked about before are deployment automation, version control, automated testing. Tonight, we're going to talk a little bit about loosely coupled architectures, flexible infrastructure, monitoring systems, and team experimentation. One of the things that we did, and this is just a slide from the website for what experimentation and things that they recommend, things that high-performing teams do. But the reason to give teams autonomy and to try and pull authority to the level at which the information exists is that, our industry has changed a little bit. When you're trying to solve problems, it used to be that like maybe you had software from a vendor, you were running SAP, and there was a prescribed way to use it. You had someone come in from SAP and tell you this is how you run it this way if you are going to do it in memory on Unix, and that was it. But we kind of don't do that anymore. We use open source software, which is now provided to us by cloud providers, and we're solving a minimum information problem. We're trying to take whatever services we have available, whatever skills we have, with the people that we have, and then just solve that novel problem for the business right now. And that's why this kind of methodology for experimentation really makes a difference when you're trying to find solutions. Okay, so we made one small architectural change, which is that when you use BigQuery editions, you can have multiple admin projects, but we looked at using many and what that would mean, but we used one at the moment. We created a projects, an automated set of projects for ourselves, which teams could then go and assign their resources to, just with a simple commit and approval model. How it works is BigQuery is truly serverless. We have a service account that's in that project that the resources are assigned to. if one of our batch workloads is running and they're using that service account, then the slots run in that job project, and then we write them out into a project where we save our data. Okay, so over to Oscar.
Thank you. Actually, I'll just quickly go back. So I will try to build upon what Steven explained and how we use this architecture and the observability experimentation features that came with it to manage the cost more effectively. So one thing here is in the center below is BigQuery job projects, 2 per team, development and production. We had around, when we started, around maybe 30 to 40 teams at the time. And so in order to use this effectively, right, we needed to see how the jobs are running on those projects, behaviors of different teams, their consumption, cost, resource requirements, and things like that. But there was a big problem there to sort out first. And that is basically we needed those teams to move their jobs to those projects. Because when I say jobs, it's like, think about anything that runs on BigQuery. Your ad hoc queries, your production, DAGs and scripts or dashboard extracts, etc. Anything scheduled on Airflow. And we, in order to start observing and managing the cost effectively, we needed to do this really fast. And what you can see from this graph is that, for example, if you look at January 2024, that means only 14% of the production workload on BigQuery was running on some team's project. 86% was on that legacy single pot that sort of everything moved after basically the merge of the companies, and everything sort of had been running there. And that's not effective, right? Because it's just a big giant pot. We don't know which teams actually sort of requiring more resources or how they're behaving. It was difficult to manage. There were thousands of DAGs running there. Metadata was weak, a lot of legacy things running. Teams have left, people have left the company, or teams have been reorged. So it was difficult to track the owners as well. So we had to come up with, a solution. We developed a script that would help teams to easily relocate their DAGs with a couple of clicks. We did a lot of workshops. We tried to explain the value of it, how they can also easily monitor their team's resource consumption. We did a lot of stakeholder management, and we were able to quickly move it up, as you can see. So we started the mass sort of mobilization around March, and by pretty much June, we were able to reach 92%, and the rest is really just deprecating some old redundant stuff lingering in the legacy project. This also, apart from cost management, this helped us with a lot of different things as well. It improved our governance because all these projects are independent entities. They would have their own service account associated with them. All the production jobs they need would run on their projects, separate from other teams, and they would have their own resource allocation. And we would be able to manage the least privileged data access better, because you would give to that individual account based on requirement, the data access, and also fine-grained access on top of it. And this happened with, of course, ownership mapping. As I said, the metadata was very weak. As we moved things, we were able to update the ownership of those jobs running as well. And then a good benefit is like immediately redundant things became very visible. And that was sort of an immediate cost-saving opportunity for us. So as we moved all those jobs to teams, we had now basically achieved a new level of observability. There's a lot going on here in this dashboard, the graphs that I'm sharing here. But what you can think about on top left is that basically every color there is some team running something some time of the day on BigQuery. And we have this visibility down to 10-minute intervals. We have breakdowns of, teams, managers, budget owners, source applications running from, the DAGs or tasks it's coming from. If it's a human, account, which user is running that. We have and then we have filters also break it down as well. So basically, this enabled, in some way, a user behavior analysis in terms of BigQuery usage. Every spike, every dip we have seen there gave us some new insight about how people are using BigQuery. Bottom right is a more aggregated, faster version of this dashboard for leadership to break it down by any hierarchy they want for working the cost management work with their teams. So with all this information we gathered, we were able to baseline the workloads, right? We understand the correct, true impact of migration. Takeaway was just a monolithic sort of workload coming in. We didn't know what team was costing, what kind of requiring what kind of resources on BigQuery, and we were able to see that. And a very important thing is that we were able to see the behavioral differences between using Redshift and BigQuery. For example, one important case is that, at least at the time, Redshift was not utilizing partitions, and the concept of partitioning and partition pruning is very important on BigQuery. So imagine basically half of the company moving over without having any muscle memory of using partitions in queries. And actually, another thing is that, again, at least at the time, there was the, maybe the perception of things fail at Redshift, but somehow it runs on BigQuery. It just works, right? So which meant that people not necessarily thought about optimization, and they were running gigantic jobs on BigQuery. And from the Just Eat side of things, we also observed the duplicated activities, legacy data warehouses impact on costs, so modernization and decommissioning started. So basically, we just ended up having a lot of different teams with very different use cases that we can manage. With this information, we started allocating the costs and seeing how we can manage it. We started our experimentation. When we started, basically what we did was, for every project, for every team, production or development, we had separate reservations, so meaning that we have allocated them resources individually. So this helped us improve our engagement with the teams. They were checking their jobs, checking their SLAs, coming to us with requesting more resources. We were identifying the bottlenecks and what can be improved. And we obviously we prioritized stability and SLA because we didn't want to create any kind of inconvenience while all this was happening. We continued observation and tuning, and then we then moved to a state where we started clustering things. So based on the team sizes, based on purposes, so we were clustering maybe based on, let's say, some teams of production jobs of some teams and maybe development jobs of some other teams into less number of reservations, which means they would still have their projects running independently. The computation would be separate, but the slot management would be in pools, basically shared pools. And we continued. And then we reached to a state where we have more inputs that we use for clustering. We used purpose, team size, but we also use time zones as well. Because as Steven mentioned, we have teams running their jobs all around the globe. So it became apparent that we can cluster things based on that as well. Because if you have only burst resources users maybe running ETLs just some part of the day, you don't need to have committed resources allocated to you, and you don't need to pay for a contract for a year or 3 years for that. Just using auto-scale on-demand slots would be more practical, cheaper even. But if you're a team that is running jobs constantly, queries or some production deployment whole day, it's better to give you some dedicated resources. And the important thing here is that these are not steps that took months and months to work on. We had to work very fast, and that was the flexibility of this enterprise edition of BigQuery gave us, because we were able to do this very fast and impacts could be seen instantly. So with all this information we gathered, with all this work we did, we were able to already achieve some significant gains in terms of cost saving, but you can only do so much with manual work. So typically the behavior is that teams first ask for more resources before thinking about optimization. Let's say they have new jobs to deploy. Maybe they are growing as a team. They have more users running queries. So they would ask more resources first instead of thinking about optimization, and that's not scalable. And yes, we have dashboards, all the visibility, but we have a lot of different teams with a lot of different priorities and a lot of different skill set as well. Not every team has data engineers as well. And just showing them, hey, look at this dashboard, nice, you can see your costs and everything was not enough. So they would just say like, so what can I do about it? Basically, we want to help with this situation and bring automation to this and some structure and scalability on managing costs and helping with optimization. We went through an intense period of analyzing a lot of queries. We researched online about BigQuery engine behavior and useful tools that we can maybe use for this purpose. We found some good stuff. For example, Google Cloud's public library has an anti-pattern checker written on Java. It wasn't very applicable to our use case, but it inspired us a lot because of a lot of reasons of the scope that we wanted to cover. We decided to develop something from our own from scratch. So we developed an application that would check on job ID level for any query being fired. It would be something light to run as a cloud run on, and it's using Python. It's using the fantastic SQL Glot library. If you don't know, please have a look. It's great for SQL parsing, and it would rely on BigQuery metadata. It's based on real queries from Jet, and it looks something like this. It's a simplified version of it, but it's just checking your query and seeing if you're using select star, for example. As you know, select star is suboptimal to using queries. Of course, it's more complicated than that because we check some other cases to make sure that's really having an impact on cost. But it's something like this, basically. And we created a dashboard about this and on team level, and we couple this with the cost monitoring dashboard that I showed earlier. So it will be something like this. We have, how many now? 12, I think, anti-patterns that we're checking for every job running on BigQuery. The ones on the left are the stuff that are immediately fixable easily, usually having a lot of impact on the cost of the computation cost. The right ones are also critical in certain cases, but it's a case-by-case approach. And we made this visible for basically everything running on BigQuery. Initially, it was just this dashboard running daily for every jobs that were executed the day before, but also we brought it much closer to the development experience. Now, whenever you create a pull request for deploying a job for your scheduled production, it would check your query. Also, you can use our UI for having dry runs. Basically, you can copy your query on it, click the dry run, it would tell you like the optimization opportunities on your query. We did a lot of workshops. We prepared video tutorials. We basically, I think even personally, I think I had meetings with pretty much every data team. We received a lot of positive feedback, a lot of engagement. Data engineers really loved this. They contributed, they provided a lot of feedback. People who wanted to learn more about running SQL effectively had received this very well as well. So let's go back to that original dashboard. Think about this and think about maybe yourself or your team, and you see something costing a lot on this graph. Imagine you highlight this area, and then it brings you this on job ID level. What the DAG was, who executed it, what was the query, what were the cost metrics there, and what were the optimization gaps and the patterns for that individual job. So you can download this, you can export this to a Google Sheet and start working on it. So I think the animation didn't work here as well. We're going to make this open source, so spoilers. So let's talk about the results as well with all this work happening. We achieved significantly lower year-over-year cost. So if you compare what happened before migrating takeaway into BigQuery, so we had cost of BigQuery and Redshift, and now we have only BigQuery. So the cost is 39% lower. This includes year-over-year growth of the company as well. We have 40% less commitments. What does that mean? We have 40% less sort of yearly or 3-year contract with BigQuery about slot purchases. We manage things with on-demand slots, which should be normally as a unit cost more expensive, but actually we are able to manage with all this workload management. We're doing it. We're doing this without cost increase. And the important thing here is that as we're doing a lot of continuous optimizations with on-demand slot usage, the impact would be more imminent because it would not reflect the same if you had everything on contract. As I said, the anti-pattern application is reducing costs continuously. We automated ticket creation on Jira. Think about those job ID examples I showed you. If you have a recurring DAG costing a lot with a lot of optimization gaps, the application would create a ticket to you. We had hundreds of tickets created and completed. And the stat is that on DAG level, it shows 47% on average cost reduction. And we were able to get a lot of additional actions on this as well. For example, these are just some of the examples because we have the situation where also if you're scanning a very large table without any partition set up, that's also a stat that you can see, right? So then with that stat, we work with the teams as well, also improving their designs in their tables. Or if a team is using a lot of distinct functions, there might be a data quality problem there. So we work on that as well. An important thing here is that, as you would probably agree, cost management is not the most fun thing to do. It's quite a contentious topic. We're not the budget setters, Steven and I, but we are in budget discussions as well and other things. We try to make this as scalable and as fun and as engaging possible, managing this on the company level without breaking our necks. And also, work with other teams as well, socialize with them, talk about, query optimization and things like that. And we try to do this without, a no blame approach as well, because if I go to your team and say like, hey, your jobs are not optimized, it's not because you're doing a bad job necessarily. It's something that you may not know because you're using BigQuery for the first time. So we wanted to learn and teach and sort of improve together, which has contributed significantly in cultural change in terms of data engineering as well. As I said here, we're working on making this open source as well, so hopefully some others can find value in this as well. It's heavily tuned for BigQuery, but it's easy to optimize it for other dialects as well, SQL dialects. So I would be happy to work with anybody interested in this as well. And yeah, that's it. Thank you so much.
All right. Any questions?
Okay.
Questions.
So what do you think, how much optimization space do you have left? I mean, did you hit the bottom? Have you optimized everything already, or are you how close are you to the optimal state?
I would love to say that we have exhausted most of it, but no. The thing is that I think we were able to capture a significant portion of really costly things because that was also impacting SLAs for those teams too. Some teams with more data engineering resources, I think they have matured quite a bit. But there are some other teams holding a lot of assets and not enough data engineering resources. It varies there. It's not very optimized there yet still.
Yeah, I think it's just a real ongoing journey, right? We have new stuff being run all the time. You will never catch up to, optimizing everything as new stuff is added.
But I thought you had maybe, let's say, already developed, let's say, best practices, and every team would do new things according to your best practices. So there would be no leeway for optimizing left right from the start.
So the anti-pattern checker and the messages that we send on check-in for new queries, we don't enforce running, the optimizations in those queries. a lot of times you might be running a job and actually you're doing in something that's not particularly suited to SQL, for which we have other solutions for within the platform, different interfaces you can use. But at that moment in time, you have a person with skills in SQL that's stitching millions of events back together to do something. And what we'll do is we'll come around to them and say, hey, you can do this another way. Here's another tool that we can give you to do that. So it's just like a constant challenge, but at least we created feedback, right? You can't imagine how difficult it is to run and manage something this large with so many events coming and streaming into the platform with just no way to see what's happening. We were kind of fighting blind. And, I think all the teams have contributed, but I think the anti-pattern checker and all the work that Oscar's done has been, really particularly helpful.
Okay, I see a question. What percentage of data you're dealing with on the ingress to BigQuery is streamed versus batch?
So you caught me out now. I can't tell you off the top of my head. I could check. I know how much data is everywhere at the moment, but I actually had the ratio. I don't know. I'm really sorry. There is a lot of both that I can say.
But I think the majority is right now one way or another.
Yeah.
One way or another. We have a lot of different solutions for real-time ingestion. I would say a vast majority of it is streamed.
Where is your source data coming from? Do you ingest everything into BigQuery?
So our source data is coming from information from different markets all across Jet. So all of those countries that we were talking about earlier on, all of those different markets, all of the data flows into the Just Eat kind of like streaming data lakehouse.
Yeah. I think one thing I can add here is that, no, we don't ingest everything. One important thing here is that it is we provide this as self-serve capability. So we handle all the services engineering going behind it, but data engineers can onboard the topics that they want to ingest. So that is basically whatever analytics purpose is needing it, then that data source would be ingested.
How about AWS Athena? Did you explore it?
Athena is great, actually, and we do use it in different parts of the company. But the major components of the data platform as it is are in GCP, and actually that streaming model, which was pioneered by the people who originally built the Just Eat data platform almost kind of like a decade ago now, were really ahead of the game. It was at the time when the kind of like Martin Kleppmann and turned the database inside out and really pioneered what a lot of people are working towards now in third generation data platforms. But, kind of 10 years ago, we were just in the right place at the right time.
DuckDB.
You can take this one because you know how I feel about DuckDB.
Maybe share your views.
I don't know. I don't have a lot of good things to say about it, so I'm going to not say anything.
Okay, some questions over that way. You want to go this one first? Might have to pass this back. Let's see how it goes.
Thank you very much. Now, it was quite interesting to find out from a platform engineering perspective on the fact that you revealed that auto-scaling actually reduced costs, which I find quite surprising. Because when you do auto-scaling, especially with in this kind of scenarios, whether it was data warehousing or data lake environments, it's the only person who gains out of auto-scaling is the public cloud provider, the hyperscaler, because he's allocating more resources which you're paying for.
Not at all. Actually, it's amazing. It's really reduced costs for us. Our headline number was we reduced costs by 39%, which is amazing if you really think about it. And a large part of that was the auto-scaling capabilities that were provided by Additions. So you saw those projects that we had. They're like a container for the resources that we're assigning to each workload, right? Now, a lot of those workloads, you have two choices. You can buy up to a commitment, and then I can have so much capacity, and then my stuff can't run. Which when you have a long, complicated graph of all sorts of different jobs that need to finish to make sure that your data is processed by a certain time to make sure that the numbers are there for the business at, like, say, 9 a.m. on Monday, the way that you use autoscaling is that not all of those workloads need to run slow. If you work out the cost for committed slots, which we did in great detail, you can say, well, I mean, this job can run much more quickly if I just provide autoscale slots and it'll finish, and then it'll have a knock-on effect on all the different jobs in the graph of jobs that need to happen. So actually you really accelerate processing. You allow yourself to spend less money by allowing something to finish quickly that needs to finish, while other workloads that you can cap and let them just run will run.
Thank you very much. That was a big takeaway from this talk tonight, actually, because I've always suspected that the hyperscalers were making money out of autoscaling. But
don't get me wrong, they're making money.
Thank you very much.
Maybe one thing I can quickly add is to, clarify, they are not autoscaling to infinity. we do have ways to sort of cap it, and it's very easy to cap it, by the way, but it's just we have ways to manage it with those teams. So it's not like they get resources as much as they want. We try to balance it out with these information we provide and ask them to optimize things first as well.
Yeah, so the nth degree of that is that we're working towards total cost of ownership for our data sets. So we can tell you, this is exactly how much it costs to create and curate this data product. And then as a business, you can say, we make money from that, so it's worth doing that processing and having that information. That's kind of like a real goal of ours.
Thank you very much.
Good thing is...
Okay, one more over this side. It's okay, it's cabbage.
Yeah.
What it's for.
And it's not making noise, which is nice.
Yeah.
Hi. So for data streaming also, you're using Airflow or some other solution you have implemented?
Well, I should let you take this one.
Sorry, automate the cost management?
For data streaming, what technologies are we using?
So we have a portion of it is basically put it into some kind of a event bus, and then we pick it up in PubSub, and then we have data flow jobs which are quite highly scalable. That's one of the good things about something we're also happy to use. So we have data flow jobs, and we have other methods of sync methods that you can use. Basically, either using GCP services or other things to put the data into BigQuery, manage the partitioning, the schema definition, and things like that. And then we have Kafka solutions that we are using because portion of the application engineers and data producers are using Kafka. So we have, again, a solution for listening to that, listening to those messages and bringing them. And two things. For Avro, you can use Avro's own capability and services that GCP provide for managing the schema and then putting it onto BigQuery. For JSON messages, we have a similar method to use where we use for the other event pass methods for inferring the schema, using an application for that, and then using data flow to put it into BigQuery again. And then, of course, we have data stream and data fusion for CDC solutions too, which is also working real time. Yeah, so that covers pretty much majority of things. And then we have API service as well that if you want to use to hit, send events directly, and it goes through our, again, validation processes.
Yeah, okay. One of the things I'll add is that it's extremely cost effective. Our price per message for all of those billions of messages going in are tiny fractions of a penny due to the efficiencies of using data flow. It's really scaled amazing for us. And, so we did some new stuff with user behavior data using Snowplow and massively increased the number of messages that we were sending via the API through into the data platform. And it just scaled. That's the sort of thing as a company to kind of we 30x our, it's a lot. And no one noticed. That's just good engineering. We scaled out horizontally and everything just kept working.
That was very helpful. Thank you.
Okay. Thanks, everyone.
Thank you.
And that's us wrapped up for the evening. Thank you so much to our speakers, our sponsors, all of you for attending. We will head to the Conductor pub, which is just outside. Please return these key fobs on your way out. Next April, we're not the first Wednesday of the month because that is on the same day as KubeCon. So it's going to be a bit busy. We're going to be in the second Wednesday of the month. Other than that, have a good evening. See you next time.